In this series of videos I'm attempting to repair and restore this Osborne OCC1 vintage computer. In this series of videos so far I've carried out some repairs on the main board and replaced a few RAM chips, refurbished and repaired the floppy drives. I've completely dismantled the keyboard, had a lot of problems with the keyboard, and had to take the membrane off and separate it and clean it and modify it slightly. I've now reassembled the keyboard, and in the previous video in this series I was showing this boot up to CPM, and it was booting from a Gotek and also from actual floppy disks. And the way I was creating the disks is I had a disk image, I connected the Gotek as a floppy drive emulator if you're not familiar with them, and I'd made an image for the Osborne using the proper boot images, connected the Gotek as drive A, booted to it, and then I used drive B as the target to copy disks. Now, one of the complications on working on this particular version of the machine is it's got the dual density option for the floppy drives fitted. And again, if you're not familiar with that, there was the original machines had a single density drive system, and the dual density was implemented by adding dual density drives and a daughter board that plugs onto the top side or underside, depending on which way you've got the machine, of the main board. And it gives you the ability to use the machine to read single or double density disks, and you can write double density disks as well, and I was writing double density disks to make the boot disk. So the way these machines, and the way most machines that handle multiple densities work, is when they first try to access a floppy disk, they will read a sector, and from the header information that they read, they will determine if the current density setting that it's kind of guessed at, which is normally it starts with single density, but if it turns out to be a double density, it tries again, and if that fails, it comes up with an error message. But if that succeeds, it goes ahead and reads the disk in dual density mode. Now, this boots up in dual density mode using the dual density boot disk, but I want to show you a fault that's developed in this. I wasn't really going to make this video, I was going to just repair this, but because it could in theory get to be quite a complex repair, although it seems something fairly trivial, it's getting fairly interesting fairly quickly, so I thought I would include this. Usually when I'm repairing equipment, I only show a small handful of the repairs I carry out. I may mention I've repaired something, but I only show a small parts of the overall process in order to stop the video series getting too long and boring. But this got fairly interesting, and although the machine was working so that I could format floppy disks, copy floppy disks, it now won't do that. I'll show you what it does. So if I've got a boot disk in drive A, this is, again, it's upside down, so in this case drive A is on the right, drive B is on the left. So drive A has got a high density or double density boot disk in it, and the drive B, the one on the left, has got an unformatted disk. Because the disks are the same whether you use single density or double density, the machine can't tell them by physically, there's nothing physical about the disk that it can examine to determine which is which. It only does that from the information that's written to the headers on the disk. And normally the machine itself is responsible for writing that information, so when you format it, you should get an option to format as single or double density disks. But we'll see what happens. I'll turn this machine on, just wait for the display to come up. So we've now got the display. We'll now boot to drive A. If you've seen any flickering, by the way, that is, again, it's just the camera. It's not doing that in real life, so it's not like there's a key held down. So I'll press the return key. Now already there's a clue there as to what's going on. Excuse the noise outside, we've got a bit of a thunderstorm going at the moment. Hopefully you can hear me okay. So I've tried this with various different disks and different images, and it does the same thing every time. So what's happening, if we boot to CP/M, and we can read the disk without any problem at all. So as you can see, as I said, it's upside down, but it's reading the disk fine. But if we try and format a disk, so I'm trying to format the disk. Now notice, firstly, it didn't come up with the option to select either single or double density formatting, but now it's failing to actually format the disk. Come up with an E at each step, so that's a fail, and at the end it will say that it's failed the process. Now when this fault started up, it would randomly sometimes show the option for single density or double density, but it always failed to format, and now it just doesn't show the option whatsoever. Now if you're familiar with CP/M, or rather if you're not familiar with CP/M, the way it works is CP/M is intended to be a multi-platform or cross-platform operating system, and so for that to work, the general core of CP/M is fairly fixed. You can modify it, the source codes are readily available, you can modify it and rebuild it if you want. But normally what's done is, in a machine like this, it's designed to boot CP/M. So CP/M is the core system, and it will have functions such as format, but the software in CP/M itself is not really responsible for directly accessing the drives. It's kind of a layered system, so you have the kernel of the system, which is CP/M, and then it has a kind of outer layer, if you like, that interfaces between CP/M and the hardware, and that outer layer is normally what you'd refer to as the BIOS of the system. So in this case it's the sort of BDOS and whatever for this particular machine. We looked at that in an earlier video, and the functions provided in that are in the Monitor Rom. I did say, probably a bit misleading, but I did say in a previous video that that monitor only puts up the greeting message when you boot it up, and has a bootloader to load CP/M. But it also contains some of the interface functions for writing to and reading from the floppy disks, amongst other things. So those low-level functions are provided by the Monitor Rom functions, but CP/M, but they're done in such a way that they are standard and consistent function calls that CP/M can make use of. So the issue here is where to start looking. So what I've done so far, I've only really just started investigating this. As I said, I was using the Gotek. I've tried it with another Gotek. I've got more than one, and it does the same thing. I've restored the original image I was using on the Gotek, tried different floppy disks that I knew were working, and they all do exactly the same thing. They are not allowing me to write anything to the floppy disk, whether that's to copy a file or to format the disk. It's not writing at all, so it would seem to be that it's a fault with the drive, but it isn't. It does this with all the drives. I've tried a couple of spare drives that I have. It does the same thing with the Gotek, and as I say, it was working, but there is something very odd going on with this. And what is odd about it is the fact that the apparent behaviour of the operating system is different to what it was, even though I have reinstated the original operating system exactly as it was when it previously worked. So the way to start looking at what this could be is to start with the basics of the interface, and because it will read the disk, then but it won't write. I started by looking at the read-write data going into and out of the floppy disk. So I'll just flip this board up so you can see it, and I'll show you what I've found so far on the scope. So what we're looking at here is of course the main board and the two daughter boards. The daughter board on the left, the one I have the scope attached to, is the double density interface board, and I've got the scope probe connected to the double density enable pin going into that board. So we're looking at this point here, and this selects double density for this interface. It does several other things as well, and it's not just a case of that line being high or low to create double density, because the format for double density writing to the disk is different to single density. But it's indicative of what the machine thinks it's supposed to be doing. So that's the point we're looking at. It should be low when a double density disk is detected, and it should go high for single density. So we've got the machine booted up, and what I'm going to do now is, it's the yellow trace on the scope by the way, it's currently low. I'm going to try and boot to the floppy disk again, so I'm going to hit the return key. So notice that that line has stayed low. CPM is now running on the machine, and as you can see, it detected or at least it appears to have detected a double density disk, and so it selected double density. That line comes out of one of the PIAs on the main board. It's actually one of the PIAs that you can't see, it's underneath the video adapter board. But what we'll try and do now is format the disk, and it does this irrespective of whether I have the disk I want to format in drive B or drive A or your GoTech. It does the same thing every time. So we'll try and format the floppy disk. If you keep an eye on the scope, so as you can see, the line's gone high, indicating that the machine thinks it's a single density disk. Now it's actually unformatted, and it should have given me the option to tell it to format the disk as single or double density, and that's what writes the information into the floppy disk header, so that when the machine comes back later to read the data, it can decide that it's a double density disk, because that's what it set the header information to indicate. The fact that it is by default jumping straight to the single density option is fairly strange, and that's why I decided to make this video. It's a fault. I've seen a similar fault before, but not exactly like this. This is a new one to me, but it seems very odd that it's it's identifying the disk correctly when it's reading it, but it's not allowing the formatting of a double density disk. It's not even giving the option to do that, and so that's kind of strange. Now unfortunately, this is another example of where this machine is a real pain to use, because firstly, the design of the electronics for the floppy drives is not standard. They didn't use a standard interface for the drives. I have no idea why they would do that. This machine was designed at a time when everything was becoming standardized, and so if you wanted to get into the computer market, the best way to do that was to fit in with what the sort of general way of doing things was. It's fine to come up with new ideas and new ways of doing things, but to just drop something in that it doesn't have any advantages, it doesn't bring anything new to the party, it just makes it more difficult to actually work with. Now what I would normally do at this point, as I said, the behavior for the interface between CPM and the floppy drives is by virtue of the BIOS that's loaded from the it's actually loaded from the floppy disk image, but it's not directly part of a CPM, and part of the behavior for the low-level interface comes from the Monitor Rom. What I would normally do is modify the Monitor Rom so that where it checks the density, it always returns double density. It's fairly simple to do that. This means changing one instruction. Now, that's what I would normally have started with. I just would have made a simple change to the ROM. Unfortunately, the ROM is sitting underneath this daughter board, and because of the way this plugs into the main board, it's very likely to damage the sockets every time you remove it. So there's probably a very limited number of times this board can be removed without having to do some serious work on the main board. Very odd design. I really do not like this. So I can't, and the ROM is underneath this, so I can't get the ROM out. This ROM down here is the character ROM, it's not the Monitor ROM. The ROM I want is kind of underneath this board, and although this is not difficult to get out, like I said, it can damage something every time you do it. So that's the route I would normally take, but in this case I want to look at other things first. Also, it would be nice to just clip the logic analyzer onto the PIA that's responsible for setting the density select bit, and I can make sure that it's actually being told to do that. It's not an internal fault with the PIA. It's not socketed, unfortunately. But again, I can't do that because this board is in the way, and the PIA I want is under the board in this location. So overall, the way this machine's designed makes it extremely difficult and cumbersome to do even fairly simple fault finding on, as I really do not like the way this machine's been laid out. It's also an odd fault, and I thought it might make an interesting series of videos in its own right, so I've decided to include this. What I've decided to do to try and track this down is to effectively try and figure out where in the code it's going wrong. And so the easiest way I can do that, bearing in mind how this thing is physically put together, is I can attach the logic analyzer to the main CPU, the Z80, and we can work our way through the code in a similar way to the way we looked at the faults earlier in this video series. So what we'll do is we'll hook up the logic analyzer and we'll locate the relevant sections in the code. That's the BIOS, BDOS, and also we can track through CPM itself, because CPM will load, it will go into the copy function and the format function, and so we can follow it through and see exactly why it's either failing to give the option to format in double density, or why it's automatically switching to single density. And the reason I'm saying it's automatically switching to single density is because, as I said, the noise it makes when it boots up is not as it was previously. It originally seemed to default to double density. That is, when you heard the floppy disk reset, it immediately went and started reading sectors. What it does now is it resets, reads a sector, resets again, rereads the sector, and then loads CPM. So I think what it's doing, it's just defaulting to single density, and when it comes to formatting, that seems to have had some knock-on effect where it's no longer giving the option to format as a double density disk. So hope that all made sense. It's going to get possibly a bit complex. If you've seen something like this on your machine and you found out what it was, then please leave a comment. Otherwise we'll work our way through and see if we can figure out exactly what's going on. One other thing I should point out that I've already done is because the RAM chips on this can of course fail at any time, and as I've said previously, when you start bringing these machines back to life when they've been sitting in a garage or a loft for a long time, you can get a kind of series of failures that tends to slow down once you've been using it for a while, but the first few days of use you can get random failures, so it could have been another RAM chip failure. So I put the Fluke 9010A onto this again and ran it through the entire Bank 0 RAM doing a long RAM test, and it didn't come back with any errors whatsoever. So I'm fairly confident the bank 0 RAM is working fine. Haven't tested the bank 3 RAM yet. That's these two chips. I'm going to pop these out before I do anything else and just put. I've got a tester I can test these in. So I'll just test those. I don't think it would have any impact, but I'm going to do that just to eliminate them. These hold the bit information for the video display. One other thing that's probably worth pointing out at this stage is the double density bit that comes out of the PIA. It's an 8-bit wide port on the PIA, but the other 7 bits are used as part of the video drive circuitry, so kind of a weird mix of things they've got going on. So again, could have something to do with that, but either way it did work. It's not working now. Restoring the image I started with for CPM didn't make any difference, so it looks like it's most likely to be a hardware fault. Doesn't make any difference if I swap the drives, does exactly the same thing. If I fit Gotex, it does the same thing. So it looks like we've got a fault somewhere, either on the main board or one of the 2 daughter boards. I have also tried a replacement ribbon cable for the drives, and it still does the same thing, so I'm fairly confident that the fault is somewhere in the main board, and that it's showing up. I think it's probably a side effect to some of the fault, but we'll see what we find as we proceed. I've printed off the first section of the code that we're interested in looking at, and this is the code that's in the Monitor Rom, and the first block I'm going to have a look at, just to really try and get some idea as to what's going on in this machine, is the this is the sense density function. So whenever the machine wants to examine the density of a disk that's in one of the drives, it will call this function. It reads one of the sectors on the disk, looks at the header information, and then uses that to determine what the density of the disk actually is. So the reason I want to look at this first is because if we try and format a disk, it shouldn't really be trying to sense the density of the disk. It should be allowing us to define the density of the disk. So we'll see if it calls this, and we'll set up the address on the logic analyzer, and we'll see at what points in the boot up sequence, and also when we try and format a disk, if this is called, if indeed it's called at all. So I'll move the camera. I've got the logic analyzer hooked up to the Z80 on the main board, and we'll start by setting up the analyzer trigger at this address. In fact, if you recall, a lot of the addresses in this Monitor Rom are offset, and in this case it's 16 hex again, so we need to add 16 hex to this address to allow us to trigger at this point. I've got the analyzer set up to trigger at address OC7F, which is the first instruction of the function we want to investigate. I've got the Osborne booted up at the welcome screen, and so we'll now arm the analyzer, and I'll press the return key on the Osborne to get it to boot from the floppy disk, and it should trigger this function. It should check the density of the disk before it tries to boot from it. And it has indeed triggered the analyzer, and the machine has booted. So we'll just check to make sure we're in the right function here. If we look at the source code, we should see that the first values here are 3E02 and then 3205EF. So if we look on the analyzer, we get 3205. If we scroll across, the next one is EF. So we are indeed at the right point in the code. Again, the way to determine where to look in this data is to look down here at the read line, that's the blue line, and in general the rising edge of this line in this particular system is the best place to look to examine what's going on with the data that's been read. You do sometimes need to check other lines as well, but in this case we're just looking at some basic ROM access, so it's fairly straightforward. Okay, so what we'll do now is we'll try to format the disk, and we'll rearm the analyzer, select the format command, and straight away we've triggered, so it's checked again. I suspect it did that to read the source disk. I think it did that to read the CPN disk. It was reading the copy instruction, and again we've got the same data, so it's at the right point. We'll rearm and go further, so I'll now select the format menu option, select drive B, and we'll hit return. And once again it's triggered at the same point, but this time it's triggered while it was trying to access, or just before it tried to access drive B. So we are getting to the right point in the code. We are getting to the start of the sense density instruction or function, and so what we'll do in the next video is start working our way through this and try and figure out what's going on. If you have any ideas as to what you think it might be, or you want to hazard a guess, then please leave a comment, but it should make a fairly interesting repair.